Hello students, myself Vinayak Prasad. Today we are going to start with the previous year's question paper of physics of class 10th, right? See here. This is the marks distribution of chapter, that is current electricity 2020. 7 marks questions came from this part. 2021, 9. 2022, 6 marks questions came from the electricity. And in 2023, 8 marks. And last year, 2024, 7 marks questions come from electricity. And 5, see here, magnetic effect of electric current, 2020, 6 marks question came. 2021, 5 marks questions were there from. And 2022, 6 marks questions were there. And 2023, 5. So you can analyze here that how many questions are coming or how many marks of each chapter they are containing, right? So it will be very easy for you to understand that if you will see human eye, which is very easy chapter, 5 marks question came in 2024. See, this is very easy to score very good marks in this chapter, guys. You know well that it's only of 20 minutes chapter is there. There's nothing more than that. If you will revise for 20 minutes, you can score good marks in this chapter. Light reflection and refraction, you can see here 2024, 7 marks question came from. And 2022, if you will see, 17 marks questions were there from light chapter only. So it's very easy to score, good marks in physics. So we are going to start with previous year's question. See here. So this is the, previous year's marks wise weightage is there, 2024, 23, 22, 21 and 20. Electricity, their first is electricity, magnetic effect of electric current, light refraction and reflection, human eye and colorful world. So you can see here how the marks came from the 2022, you can see here. 17 marks question I have seen you in the previous slides, you can analyze from there as well. Now, yes. So how you would connect 3 resistors, each of resistance 6 ohm, so that the combination has a resistance of 9 ohm, also justify your answer. See how you will connect the 3 resistors of each, that is what, 6 ohm, to get what, the combination that would be 9 ohm. See guys, how we can connect this. See here, let's suppose we are having this resistance, right? If this would be the combination of what, 6 ohm, we can easily connect this 6 ohm, 6 ohm and 6 ohm. What I have to see here, 2 resistors in the parallel combination and 1 in the series combination, and let's try and we can get the answer. How we can get 2 resistors are in the parallel combination. So what we can do for this, 6 into 6. This will be what? And 6 plus 6. We will get what? 6 6 is 36. And 6 plus 6 is what? That is 12. And when you will cancel this, you will get what? 3 ohm. And we are having what? 1 resistor in what? The series. So total we will get what? 3 plus 6, it will be what? 9 ohm. So we can get by this as well. So see guys, you have to practice this question so that we can understand that how we can get this type of questions answers, right? See, so 6 plus this is in the parallel combination, and most of the students are doing what, 1 upon 6 plus 1 upon 6. For 2 resistors, you can do what? You can directly solve like this only, because if you will go to take the LCM of all these and you will go to answer this question, it will take time, right? But you can directly solve like this as well. But as here it has been mentioned that is a subjective type of question, so you can use this method as well. So if you will go to take the LCM of this will be what, 6 only. So 6 and 6 will cancel out. It will be what, 1 and plus 1. It will be what, 2 upon 6. Now if this is what, 1 upon R equivalent, if you will go to find R equivalent, then it will be what, R equivalent will be equals to 6 upon 2. So it will be 3. 3 plus 6 will give you what, 9. So you can see here the solutions as well. See here, R1 into R2 upon R1 plus R2 plus R3, that we have done in the previous slide only. So we have got what, 6 into 6 upon 6 plus 6 plus 6, that is what, 9 ohm. Now the next part is what? In the given circuit, calculate the power consumed in watt in the resistance. First of all, we have to understand that these two resistance are in what? Series combination. So if this is in the series combination and the battery is of what? 6 volt. So how we can solve? It has been asked in the question that you have to find the power from 2 watt resistance, right? So we can calculate what? First of all, before going to calculate power, we have to calculate the energy as well, right? Because we have formula. You can see here that if we want to find the equivalent resistance, then as we have seen that in the previous slide, the questions that there is 2 resistance are connected in series, so that together it will be what? 3 ohm resistance. So we have got what? 3 ohm resistance here. If we want to find the current, see here, R1 plus R2 will be equals to what? 3 ohm. You can see here, yes, this is what I have taken R1 and this is what? R2. So R1 plus R2, as these are in the series combination, so it will be 1 plus 2. So it will be what? 3 ohm, right? We have got the total resistance from this circuit, that is equivalent resistance, we have got what? 3 ohm. And there is a battery of what? 6 volt. Now what we can do here? We need to find first current. How we can find current? According to Ohm's law, V equals to what? IR. V is directly proportional to I, so V equals to IR. If you want to find I from here, so how we can find I? See here, I will be equals to what? V upon R equals to I. So we can find current here. See here, we can find what? Current. And what will be the current from this? We can find easily, as we have find the resistance. So current we can find, see here, 3 ohm resistance is there. Now current passing through the circuit will be equals to what? V upon R equivalent, that is what? Current, V is what? 6 and resistance is what? 3. So we have got what? 2 ampere. So current will be in what? Ampere. Now next you can see here, we need to find what? Power. So for power, we know that E equals to P into T. See here. And it has been asked you that you need to find the power from 2 ohm resistance. For 2 ohm resistance, it will be what? P equals to I square R, and we have found I. I equals to what? That is, we have found 6 upon 3, that is what? 2. So 2 I square means what? 2 to the power 2 into resistance. It has been asked from the 2 ohm resistance. Then what will be the answer for this question? 2 2 is 4, 4 into 2, it will be what? 8 watt. Got it? So that is what? 8 watt. Now the next question is what? Define electric power, express it in terms of potential difference and resistance, right? And the next part is what? An electric oven. We will see this question later. First, the first question we will see the define what? Power. See here, in terms of what? Potential difference. So electric power is defined as the rate at which the electrical energy is consumed or converted into the form of energy in an electrical circuit. See here, we will know that P equals to what? P equals to V square upon R. Now we can also see here, we know what? P equals to VI, right? P equals to VI. And if we will convert this I, as we know that V equals to IR, right? And I equals to what? V upon R. I equals to what? We can write I equals to V upon R. So if we will replace this I by V upon R, so what we will get here? So V into V upon R. So it will be what? V square upon R. It will be what? V square upon R. So same thing we have got here by in terms of mathematics, right? Now, so where P is power and V is potential difference, we well know. Now, the second part of this question was what? See here. An electrical oven is designed to work on the mains of voltage 220 volt. The oven consumed 11 units of electrical energy in 5 hours. Calculate. Guys, we have to very much clear. 11 units has been given to you and it has been given in hours, 5 hours. So we will take it as what? 11 kW, we can take kilowatt, right? Now power rating of the oven, current drawn from the oven, right, and resistance of the oven in when it is red hot. So we have to find what? P. Basically we have to find what? P and I and R. R is what? Resistance, I is what? Current, P is power. The three things we have to calculate from this is what? Power, current and resistance, right? So now see here, we have given what? Voltage, that is 220 volt, and energy, that is 11 units that I have told you. So we have to take 11 unit in kilowatt hour. That is what? Kilowatt hour will be equals to what? 11 into 1000, that will be in kilo, okay? Kilowatt hour. Now see here, as it has been given you that the time taken equals to what? 5 hours. So now you can see here how we can calculate. Time is what? 5 hours. Power rating of the oven will be equals to what? So energy consumed is given by what? E equals to P, P into T, and P will be equals to what? E upon T. And energy that we have, that is what? 11,000 watt hour. Now if you will divide it by time, so we will get what? Power. So if you will go to divide this, you will get what? Power. So you can see here, P equals to what? E upon T. We have seen here P equals to E upon T. So we have the value of energy, that is what? That is what you can see here, 11,000 kilowatt hour, and upon time, time is what? 5. So we can easily, if you will calculate this, this will be equals to what? 11,000 upon 5. So you will get what? 2200 watt, 2200 watt. Now, so we have got power. The second part is what? We have to find the current. Current equals to what? P equals to VI, we know. P equals to what? VI. Now I equals to what? P upon V. We can say P upon V. I will be equals to what? P upon V. And power that we have calculated, that is what? 2200 watt. 2200 watt, and we are also having what? Potential difference. That is what? That is also mentioned in the question. That is what? Power equals to, you can see easily, that is 2200 upon 220. Potential difference has been given to you, 220 potential difference. So if you will go to cancel this, you will get what? 22 one time, so 10. So 10 ampere of current will be utilized in this. Now the third part of this question is what? Current we have found. We need to find what? Resistance, R. See here, resistance equals to what? From Ohm's law we know that V equals to IR, and we are also having V and we are also having I in this question. So we can easily find V equals to, from Ohm's law, V equals to IR. So we need to find what? Resistance. V upon I will be equals to what? R. So V is what? 220. So 220 upon what? 10. So you will get what? 22 ohm. So we have found what? 22 ohm. That is what? That is the resistance in the circuit. So the resistance of the oven when it is red hot is what? 22 ohm. Got it? Now next question. See guys, this is a long answer question. It is of 5 marks. So in this question, what has been asked? Write the relation between the resistance R, electrical resistivity rho of the material of a conductor in the shape of cylinder of length L. This is not 1, this is what? L, right? And the area of cross section is what? A. Hence derive the SI unit of the electrical resistivity. This is a very easy question. We know that R equals to what? Rho L upon A. This is what? Resistance. But we need to find what? Resistivity. See here, what has been asked? Write the relation between the resistance R and electrical resistivity rho. Rho is that I have taken here, rho, right? And this is what? L. This is length of the conductor, right? And in the shape of cylinder of length and area of cross section is what? A. Hence derive the SI unit. And we have to find the SI unit of resistivity here. We can easily find the resistivity. See, we will take this A to this side. We will get what? A into R upon L. That will be what? Upon L. R into A upon L. It will give you what? Resistivity. And if we will keep the value of R, A and L, we can easily find the SI unit of this resistivity. So you will see here in the next slide, that is what? R equals to rho L upon A, and we need to find what? Rho. So rho will be equals to what? R into A upon L. Now see here, rho equals to R into A upon L. Now, substituting the value, we are knowing that area of cross section is what? Meter square. Resistance is what? Ohm. And length of the wire, the SI unit of length is what? Meter. So, this will cancel out. So, we will get what? Ohm meter. So, we will get what? Ohm meter. So, same here, we have got what? Ohm meter. So, the SI unit of resistivity will be equals to what? Ohm meter. Now, next is what? Next part of the question, if you will go to see, that will be equals, that is what? In this question, what has been asked, you have to find the resistivity. See here. So, what has been asked in this question? The resistance of the metal wire of length 3 meter ohm, 3 meter is 60 ohm. So, it has been asked what? The resistance of the metal wire of length 3 meter and resistance has been given to you, that is what? 60 ohm. If the area of cross section of the wire is 4 into 10 to the power 7 meter square. See, everything has been given to you. Calculate the electrical resistivity of the wire. So, you need to find what? Rho here, and we can easily find rho by what? See here, we are having the formula R equals to rho L upon A. So, rho will be equals to what? So, we need to find what? Rho, and we know that formula of rho is what? R into A upon L. This is not 1 guys, this is what? L. See here. So, now length has been given to you and resistance also we have given, that is what? 60 ohm into what? Resistance 60 ohm is there, area of cross section is what? 4 into 10 to the power minus 7 meter square, right? And length of the wire is what? Length of the cylindrical wire is what? That is 3 meter. So, we can easily calculate this, that is what? 3 to the 6. So, 20 into 4 into 10 to the power what? Minus 7. So, 4 to the 8, 80 into 10 to the power minus 7, and resistivity is there. So, it is what? Ohm meter. So, we can find here. So, it will be what? 80 into 10 to the power minus 7, or you can write what? 8 into 10 to the power minus 6 as well. So, both answer is correct. It has been asked in the question, that is what? If the wire is stretched, right? So, if the wire is stretched, so the length will become, because R equals to rho L upon A. R equals to what? Rho L upon A. So, if the length is stretched, that area will become half, right? If the length is increasing, so area will be also changing in the same ratio, right? So, what will be that ratio? So, if the length becomes what? 2L, we have seen in the question that the cross section of area decreases since volume remains constant. Now, so it will be what? Area will decrease by half, and if length is increasing by 2L, right? So, now we will get what? The resistivity of the material property and does not change with the dimensions. So, there will be no change in the resistivity. Although there will be change in the resistance, but there will be no change in the resistivity. So, we have done this question. Now, next question is what? So, we can see here, when length will double, area is half, the resistance become 4 times the original value, but there will be no change in the resistivity. Now, next question is what? The pattern of the magnetic field produced inside a current carrying solenoid is what? So, the very first option is what? That is in parallel lines, right? So, we will get what? This is the right answer of this question. First, why? We can see here, that is option A is correct. The magnetic field produced inside a current carrying solenoid is a pattern of parallel straight line, right? So, it is a parallel straight line, and that is in the very first option it was there, right? This pattern indicates that magnetic field is uniform, meaning it has the same strength at all points inside the solenoid. Got it? So, this is from the magnetic effect of electric current. Now, the next question is what? Two magnetic field lines do not intersect each other. Yes, see here. Two magnetic field lines do not intersect because it would mean that magnetic field has different directions at point of the intersection, which is not possible. A magnetic field can only have one direction at any point in space. So, one more thing is that what? A uniform magnetic field is represented by parallel equally spaced magnetic field lines. This indicates that magnetic field has the same strength and direction at every point in the region. So, this was the first option, and this is correct only. Now, the next is what? Name and state the rule to determine the direction of a magnetic field produced around a current carrying straight conductor. Current carrying straight conductor, that we well know that is what? Right hand thumb rule, that is of Maxwell. So the question is what? Magnetic field produced around a current carrying straight conductor, and the second question is what? Force experienced by the current carrying straight conductor placed in a magnetic field which is perpendicular. See, this is from the last year only, CBSE 2024, 2 marks question is there. So what is there? First question is what? That is of the direction of the magnetic field produced around a straight current carrying conductor is determined by Maxwell's right hand thumb rule. And the second part is what? The rule states that, what is the rule? What is the rule? Rule is what? If we are having a straight current carrying conductor in our right hand, then thumb will show what and the curling finger will show what, that we will be going to see here. The rule states that if a straight conductor carrying current is held in the right hand such that the thumb is pointing in the direction of current, if thumb is showing the direction of current, then the curling finger will show the direction of electric field. See here. Then the direction in which your fingers encircle the wire, the direction of the magnetic field lines of force around the wire. So it will show what the direction of magnetic field lines. Now the second part is what? Second part, the direction of force experienced by the current carrying straight conductor placed in the magnetic field is determined by Fleming's left hand rule. So what is Fleming's left hand rule? So see, if we will stretch our hand in such a way that our first finger, second finger and third finger, thumb, index finger and middle finger will, if they are mutually perpendicular to each other, then see here, according to Fleming's left hand rule, stretch the thumb, forefinger and middle finger of your left hand such that they are mutually perpendicular to each other, right? If the first finger points in the direction of magnetic field and the second finger in the direction of current, then the thumb will point in the direction of the motion or the force on the conductor. So Fleming's left hand rule, we know with that. So this is what the another question. Now we are going to see at what distance from a convex lens should an object be placed to get an image of the same size as that of the object on a screen. So see here, at what distance from a convex lens it has been asked. So for lens we have to see what? For that is what? F is what? Minus, V is what? Plus, that we have to see first, right? So F, V, U, everything we have to see very clearly whether it is plus with or it is minus, because sign convention is very important for this type of questions, right? Now, so the very first question is what? At what distance from a convex lens should an object be placed to get an image of the same size as that of the object on a screen? Beyond twice the focal length of the lens. Second is what? At the principal focus of the lens, at twice the focal length of the lens, between the optical center of the lens and principal focus. What will be the right option for this question? It is a 1 mark question is there. So, at what distance from a convex lens should an object be placed, right? To get an image of the same size as that of the object. So, for the same size, what we can say for this question, guys, right? There are 4 options for this question. So, what will be the right option for this question? We can see here. The correct option is C. Why C? See here. At twice the focal length of the lens, and twice the focal length will be what? That is center, right? So, it will be at twice the center of the, twice the focal length of the lens. So, that C is the correct option for this question. Now, next is what? So, when object is kept twice the focal length, image is formed at the twice the focal length of the opposite side. In such a scenario, magnification -1 and hence the size of the size is same as object. Now, next question is what? An object placed at a distance of 10 centimeter from a convex mirror. So guys, we have to mark first, that is what? Convex mirror has been given to you. Of focal length 15 centimeter, focal length has been given to you, that is what? 15 centimeter. Find the position of the image formed by the mirror. So you need to find what? Position of the mirror, position of the image, that is what? V you need to find. So how we can find the V? And find the position of the image formed by the mirror. So you need to find what? V. So see here, how we can find the V, and we know what the formula of mirror. First of all, we will be finding the given, what has been given to us. U will be always in negative in a convex mirror or a concave mirror. U will be always in negative. That is what? Minus 10 centimeter. Focal length is what? 15 centimeter. That is F. That will be for convex mirror. It will be in plus. We need to find what? V. V. That is what? Image distance, right? So we know that 1 upon F equals to 1 upon V plus 1 upon U. So we get what? And we need to find what? 1 upon V. So 1 upon U will come to this side. So 1 upon F minus 1 upon U, we will get what? 1 upon V. So we know that V is what? The image distance, right? So 1 upon V will be equals to what? 1 upon F minus 1 upon U. And we have given the value of U and V. So we can easily find this. So how we can find this? So 1 upon 15 minus 1 upon 10. So we will get what? So this minus and minus will become plus. And the LCM for this will be equals to what? 15 into 10 upon 15 plus 10. If you will solve this, you will get what? 5 upon 30, right? So 5 upon 30, this is what? 1 upon V. But if we need to find V, so it will be what? This will be the reciprocal of this. So we will get what? 30 upon 5, that will be equals to 6. So 6 centimeter will be the image distance, right? Now, the image will be formed at a distance of 6 centimeter from the mirror behind, and behind it the image would be what? Image will be formed erect and virtual, right? We know that from convex mirror we are getting what? Virtual, right? Now, here what has been asked in this question: study the data given below showing the focal length of 3 concave mirror A, B and C and the respective distances of the object placed in front of the mirror. The first is what? Mirror A. Focal length and object distance has been given to you. See here, A, focal length is what? 20, object distance is what? 45. B, in case 2, mirror B, focal length is what? 15 and object distance is what? 30. Third case, focal length is what? 30 and object distance is 20. We need to find what? In which one of the above case the mirror will form a diminished image of the object. Justify your answer. List 2 properties of the image formed in case 2. So we have to find the 2 properties, that is when object is, for the second, it is asking for the second case. List 2 properties of the image formed in case 2. And C is what? What is the nature and size of the image formed by the mirror C? What is the nature and size of the image formed by C? Draw the ray diagram to justify your answer. See here. A concave mirror forms a diminished image when the object is placed beyond the center of curvature. So beyond the center of curvature, if the object, see, a concave mirror forms a diminished image when the object is placed beyond the center of curvature. If the object is placed in between the center of curvature and focus, the image will be formed behind the center of curvature. So it is what? A concave mirror forms a diminished image when the object is placed beyond the center of curvature, right? Now, the second part is what? For a concave mirror, the center of curvature is located at a distance equal twice the focal length, that is R equals to 2F. Now, case 1, we are having what? Focal length 20 centimeter and center of curvature is what? 40 centimeter. Now, object distance is what? Greater than C. Object distance is greater than C. We have seen that. So the object is beyond the center of curvature and the image will be diminished. So if the object is beyond the center of curvature, then the image will be what? Diminished. Getting my point? Now, the next part is what? In the second case, focal length is what? 15 centimeter. Center of curvature is what? That is 2F, that is equals to 30. Now, object distance 30 centimeter and so the and C equals to what? That is equals to 30. See, object distance, center of curvature is what? 30 centimeter, object distance 30 centimeter. So the object is at the center of curvature, the image will be of the same size. We have seen in case of what? And when the object is at center of curvature, the image is of same size, right? That is just below the center of curvature. So in case of what? Third, that is what? Mirror C, focal length is 30 centimeter, center of curvature is what? That is 60 centimeter. In this case, object distance is less than C. Object distance is what? Less than C. So the object is between the focal point and the center of curvature. The image will be magnified. So The conclusion is what? The mirror forms a diminished image in case 1, that is A, as the object is placed beyond the center of curvature. Now, list 2 properties of the image found in case 2. Case 2 is what? We have seen that for case 2 we have seen object is at the center of curvature, that is what? U equals to 30 centimeter. So properties of the image will be what? The image will be of the same size as the object because it was in the at the center of curvature. Nature is what? The image will be real and inverted. Concave mirror forms what? Real and inverted case. Real and inverted image only in the one case, that is when the object is placed between the pole and the focus, then only the virtual image is formed. Next is what? For mirror C, focal length is what? 30 centimeter. Object distance is what? 20 centimeter. That is less than the focal. When the object is placed between the focal point and the pole of the concave mirror. So we have seen this case. Just now I have told you about this. The image formed is virtual and magnified. If the object is placed between pole and focal length or focal point, we can say focus between. If the object is placed between pole and focus, the image will be behind the mirror, and that image will be what? Virtual and erect. The image formed is virtual and magnified. The image is formed behind the mirror. Now, the question 8 is what? An object is placed at a distance of 18 centimeter from the pole of a concave mirror of focal length 12 centimeter. So it has been given to you what? That focal length is 12 centimeter. Find the position of the image formed in this case. So an object is placed at a distance of 18 centimeter from the pole. U is given to you. U is what? 18 centimeter. And the focal length is what? 12 centimeter. F has been given to you. For what? For a concave mirror. It has been asked for concave mirror. F is what? That is, now find the position of the image formed in this case. So position you can find. How you can find the position? See here. So we will apply the formula of mirror formula. That is what? U is, yes, one more thing is what? For concave mirror, U will be in negative. Focal length will be also in negative. So for both the cases, U is what? Negative for focal length and the object distance. Because the object is placed, we will apply the sign convention, and according to the sign convention, U will be in negative and V will be also in F will be also in negative, right? Now, 1 upon F equals to 1 upon V plus 1 upon U. We will apply this formula and we will get what? 1 upon F, 1 upon V equals to what? 1 upon V minus 1 upon U. See here. For 1 upon V, we have to do what? We have to take this 1 upon C. We need to find what? Image. So this we will take to left hand side. So it will be what? In negative. So we will get what? 1 upon V equals to 1 upon F minus 1 upon U, right? Value has been given to you. That is what? U is what? 1 upon 18. So 1 upon V equals to 1 upon F minus 1 upon U. And F is what? That is minus 12. 1 upon minus 12 minus U is what? 1 upon minus 18. Now, when you will calculate this, what you will going to get? See here. My 1 upon minus 12 minus 1 upon 18. This will become plus 1 upon 18. So you will get what? Minus 3 plus 2 upon 36. So V will be equals to minus 36 centimeter. So position of the image formed in this case is 36 centimeter in front of a concave mirror. Getting my point? Now, the lens system of human eye forms an image on a light sensitive screen, which is called as what? You can see here. So this is also from the CBSE 2024 only. This will be called as what? Retina. The light sensitive screen where the lens system of the human eye forms an image is called what? Retina. The retina is made up of what? Two types of light sensitive cells, rod and cones, which are sensitive to bright and dim light respectively. Got it? Now, the next question is what? This is from the assertion reason question. That is what? The rainbow is a natural spectrum of sunlight in the sky. The rainbow is a natural spectrum of sunlight in the sky. This is the assertion. Reason is what? Rainbow is formed in the sky when the sun is overhead and water droplets are also present in air. So see here guys, we know that when the rainbow is formed when the sun is in the opposite direction of the this. See here, assertion and reason both are true. R is the correct explanation of A. A and R both are true. R is not the correct explanation of A. A is true, R is false, A is false, R is false. We are having 4 options here. So we can see here what? See, assertion is true and reason is false. Why reason is false? Rainbow is an arc-shaped natural dispersion of light seen in the sky after rain, right? That is one point. This is mainly due to the total internal reflection, TIR is there. This is due to the total internal reflection of the light waves from the water droplets, leading to dispersion and splitting of white light into its component color. That is what we've got, right? Now, the sunlight enters the droplets by refraction from the back surface. They undergo total internal reflection and emerges out droplets to the form colored spectrum, right? Now, sunlight induced rainbow always appear in the sky area directly opposite the sun, that I have told you in the starting. That is, will be in the opposite direction. So hence, rainbow is seen when the sun is behind the observer, not overhead. So reason was wrong. Now, see here in this question, study the diagram given below and answer the question that follow. First is what? Name the defect of vision represented in the diagram. Give reason for your answer. As see here, you can see here, the image is formed outside the retina. So what will be the right answer for this question? Name the defect of vision represented in the diagram. Give reason for your answer. As the image is formed behind the retina, so it will be what? Hypermetropia. List 2 causes of this defect. With the help of a diagram, show how this defect of vision is corrected. So which kind of lens we can use in this case, that we will be going to see here. See here, the diagram represents the hypermetropia, commonly known as what? Farsightedness. This detect allows for clear vision of this, right? Now, next part is what? Which lens we will be using or how we will correct. The focal length of the eye lens is too long. This is the reason, right? And the eyeball has become too small. That this is the second part, right? Now, how we can correct this? By using convex lens, right? With the help of the diagram, so how this defect of vision can be corrected. So we can use what? Convex lens can be used to overcome from this disease. So see here, with the diagram we have tried to solve this, that we have used what? Convex lens, and by using convex lens we can correct this disease. Earlier it was what? Focus is behind the retina. Now we have brought it before the retina, we can say. So by using convex lens we can correct this disease. So with this we have completed our previous year's questions of physics from CBSE 2024. I hope you have understood this all things, and you can also conclude that which topic is more important, and accordingly you can prepare for your exam. So good luck for your exam, guys.